Right. Good afternoon, guys. Welcome to our second Steel Connect webinar, where the focus today will be on IBS with steel. Let me start by sharing more about the term IBS. So IBS is actually an abbreviation for Industrialized Building System. So other terms of IBS throughout the world can be referred to as prefabrication or modular system. And in United States, they call it off-site manufacturing or OSM. And in UK, they would refer to the same term IBS as modern method of construction, MMC. CIDB have actually defined clearly what is IBS. So it means it's actually a construction technique where the components are manufactured in a controlled environment, delivered, positioned, and assembled on site into a structure with minimal site works. So the keywords here are techniques as well as minimal site work. So throughout the years, CIDB has pushed out a few initiatives. And the most recent one is what they call a construction industry transformation program, which spans between the year 2016 and 2020. So in this initiative itself, they actually track IBS adoption in Malaysia. As you can see from this midterm review that was done in early 2019, they actually come up with the result of adoption rate. And based on this result itself, it shows that public sectors has adopted 80% of their projects using IBS, which is in line with the target by the end of 2020. Whereas for the private sectors, only 32% of the projects have adopted IBS, which is lacking behind the target which is set by end of 2020. So today we would like so that we can push the awareness or even the confidence of the private sector to adopt more IBS. Of course, there are actually different material to adopt IBS technology for your building construction. Okay, again, method. Okay, and the first type is most commonly concrete, where they will call it as precast. Okay, and you can use this for floor, wall, or even staircase. And the second method is called timber, which is normally used for trusses or sometimes temporary formwork. And the third would be steel, which is currently very common for trusses, permanent formwork like floor decking, and insulated panels. Let me share with you the history. So in fact, this approach of IBS with steel has been employed as early as mid-19th centuries. To be more exact, it was in between 1850 to 1855, where during the gold rush era in Australia, most of the investors coming from UK or other countries, they are wealthy. They don't have any means of communicating with the people in Australia to build the houses for them prior to their arrival. So some of them actually built the house in UK and ship it together when they are coming over. So upon arrival, they can actually set it up. So by 1855, the southern region of Melbourne was home to around 100 of these buildings. And typically back then, they call it portable iron houses. So this kind of iron houses can be, they have a catalog where you can choose in between different models, cottages design, or even to theatre and churches, where the biggest one could even house around 700 people. Again, it was constructed in UK, so what they did was they constructed it in UK and dismantled it and label every single member and ship it to the location where they want it to be set up. Fast forward to 1970s, these simple principles was carried forward, but with a more modern means. So the steel frames were connected by welding method, and it was used most often for roof trusses or even wall framing. And in 1980s, it was from welding to self-tapping fastening method, where we call tap in slot technology. So this accelerated and allow for easy installation on site. And it can also be used for the same function, which is for roof trusses or wall framing. And in the 1990s, we saw an improvement in the computer technology, which allowed computer-aided design and manufacturing. So in this approach, the designs are determined in the computer before it's being built. So the efficiency of building design allow for lighter weight building or lesser material use. And more importantly, for the manufacturing side, the steel members are pre-cut to precise length and sizes. So this also allow for higher repeatability, where they can actually mass produce it in different houses. So currently, this technology is commonly referred to as lightweight steel framing, and it can be used for roof trusses, as shown in the picture. And the lightweight steel framing can also be used to build wall frames, or the lesser known fact that it can also be used to build what we call floor joists, which can be seen from this picture, which is camera is standing on the second floor. And how it looks like from the bottom. So the floor joist itself will be seen as a ceiling, or can function as a ceiling from the ground floor. So that's the evolution of IBS with steel. So let's get into the topic. So traditionally, construction methods normally have a lot of on-site fabrication. So this requires a lot of material to be sent on-site just to be trimmed off and become a waste. By using IBS with steel, the components are pre-cut and prefabricated in the factory. So most often the steel members are precisely cut or measured to the design length, and no wastages will be sent onto the site. So as quoted by one of the experts that we interviewed, Mr. Chu from Enduro Frame, the foundations are normally constructed on site, but most of the sections such as wall, floor, or even cutouts for the windows and doors are done in the factory. So by doing so, you eliminate wastages to be sent on site. Or put it another way, you can actually use the material more efficiently. So here is an aerial view of an example of a clean site environment where the steel frames is installed on site with minimal wastages, which leads to my second point. IBS with steel can also improve construction productivity. So see this example where the foundation is being constructed on site. Simultaneously, the building materials such as lightweight steel framing are produced in the factory. So we also interviewed another expert, which is Dr. Chua from Monash. She mentioned that prefabrication or IBS technology, you always look for improvement in terms of productivity and efficiency. So by having the foundations done on site simultaneously with the production of material in the factory, the steel members that are bundled up and sent on site can arrive just in time for installation. So this is what we call just-in-time delivery, where upon completion of foundation, the material will arrive for installation to minimize any required space for storage on site. So IBS is still can also have fast installation on site. So the level of installation speed depends on the level of IBS approach. Here we have three types of IBS approach. So the first type is what we call site assembly, where the steel members are assembled on site. So simply put, the steel members are prefabricated in the factory and joined together on site to become what we call panel. And the second type of IBS is when the panels are assembled in the factory and sent on site for installation. And the third type of IBS is called volumetric, where the panels are assembled together in the factory to form a box. Typically, this method would have internal fit out completed before they send on site, such as tiling, the toiletries, or even wiring. So let me just run through in more detail for each of these and show you some examples. So here, a site assembly example where there was a training done. The steel members arrive on site are in bundle, as you can see from this picture, so it's occupies less space. Upon arrival on site, they actually unpacked it, and each steel members are, like I said, pre-cut, so it is assembled according to a specific drawing. So once the steel members are assembled to become panel, Each panels would then be erected and fastened onto the ground and to the adjacent panel. And here's the third panel up, fourth panel up, and ultimately you form a room, which is what we call volumetric, but it was done on site. So this method has proven to be more effective for projects that are located in rural area. Why? Well, because the logistic costs can be lower as the steel members are lightweight and occupies less space than conventional method. So the example that I'm showing here is actually a school project in rural Sabah. You can see the location down on the bottom right. So it took only 4 weeks for the material to be assembled on the foundation, including the finishing as well. Here's another example. They even painted the external wall panels. So the second example is what I call panelized type of IBS. The panelized system itself, as you can see here, is constructed in the factory and shipped out from the factory to the site. So this method, you can see it occupies more space than the previous method. However, the added advantage of this compared to the previous method is that you have less site work and you require less space because the panel arrive can straight away be installed onto the site. So recently we have witnessed this quarantine and observation hospital built in Indonesia within a record time. Here you can have a closer look where you can see the panels used for wall and ceiling are fastened easily onto the site, onto the building. So in total, the hospital itself provided around 400 observation beds and 50 isolation beds, and all within 8 days of on-site assembly. So the third method is volumetric type. So this we get example from Singapore because it's more commonly used in Singapore. Here you can see a bare bone structure of volumetric approach where the steel box is constructed in the factory. So typically the manufacturer will take full advantage of this approach by having internal fit out completed in the factory. So all the say bathtub, the toiletries, or even the wall panels are finished in the factory. So this is a specific example where you can see the bathtub, and upon arrival assembly, you can see the bathtub is in each unit already. So as you can imagine, this approach itself requires higher logistic costs compared to the previous two approach, and it occupies more space on the trailer truck. But the method itself requires less site work, which based on their statistics, it shows that it was 15 to 20% faster compared to the conventional construction method. Steel can provide relatively lightweight solution also. Now steel has a higher strength to weight ratio compared to other materials, as mentioned by Dr. Chua. So it's just more efficient material because you will require less material for the same support structure. Due to the high strength to weight ratio also, design of home can be lightweight, potentially reducing the foundation size. And this will be taken into account during the designing stage. This also has been based on the feedback from Mr. Chu, who is an experienced in this field. And ultimately, it could lower down the foundation cost. And you can determine it during the design stage. Of course, upon production of this material, the steel members can be bundled up together, so it could lower the logistic cost. So the picture that you can see here, potentially the material within this frame of picture can be constructed into a whole house, and it is shipped in one go instead of multiple trips, resulting in a more efficient logistic arrangement. Of course, it could also minimize the crane usage because of its lightweight steel frame. So the picture shown here, it shows that the example of a whole big wall panels being erected easily by 3 workers. And this minimizes the need for crane to hoist up the structure. Depending on which type of IBS, it's true that IBS will still requires lesser on-site labor. The example shown here, the framing done here in the picture, it was completed within 2 weeks by 3 skilled workers. Once the framing has been covered by drywall, you will not be able to recognize it was done by 3 workers. And the best part is, you don't have to sacrifice on quality or time. So based on statistics of this case study, which is Crown Plaza Hotel Extension, around 40% manpower was saved on site by using volumetric construction method. 40% means 40% less manpower from the conventional construction method. Furthermore, by minimizing the workers on site, you are able to minimize the safety exposure as well. So say, for example, during this current pandemic situation, less worker on site also means safer because they do not have to work so closely to each other, limiting their exposure. All in all, we can see from this slide itself, which we benchmark the site cast concrete building method, which is highlighted in yellow. A typical conventional method requires higher on-site labor, hence more cost for on-site labor, as well as more logistic costs because you are not just shipping the material that are already built, but also those material which could be trimmed away, become waste. And of course, we know that IBS with concrete surely will reduce the on-site labor costs as well as some of the logistic costs. But ultimately, for steel, we know that it would provide more cost saving on logistics because of its lightweight, and it also require same or even less on-site labors because you can have the workers lift up the panels by themselves. As quoted by Mr. Chu, light gauge steel framing prefabrication construction method is flexible enough to cater for any scenario for a project because of its different nature of IBS. And another reason for adopting IBS with steel is its design flexibility. This is lesser known, and we like to take this chance to highlight this. We know that designing with steel can be done on computer-aided design on computer. Okay. So the lightweight steel framing can be designed to curves as well. And it has been done in various occasions. For example, like this bare structure with a slight curved apex, or even in a jetty in Labuan, which has a curved roof made of this steel structure. So IBS with steel can be versatile to fit contemporary design. So this is a before, and after it's completed, you will not even notice or realize it was actually made of steel structure. And this is another photo showing a work in progress of a building. So guess what this building is will become? Turns out it is actually a fast food chain restaurant. The same IBS technology can also be used as support for external facade panels. So it's pretty flexible. Of course, steel is non-flammable or non-combustible. So rest assured it will not be contributing to the existing fire. Here is a test done by CSIRO in Australia, where the testing time itself has a peak 2 minutes of temperature where the fire engulfed the whole house. At the reading of temperature is around 1200 degrees Celsius. At this temperature for 2 minutes, the glass broken and the wooden door contributed more to the fire source, where it could jeopardize the safety. Of course, we are saying this because we know that steel framing would not contribute more fire to what already been a worst case already. So you are allowing the dwellers within the building to escape, allowing more time for them to escape. Let me just go into the future of IBS. What does it mean for IBS with steel? So modern landed house, as you can see from this picture, can blend in with the old infrastructure. So you can not only have old and new design combined together, but also it allows for easy extension. So over here you can see a breakup of a building connecting to a more modern building extension. Not just that, mid-rise apartments can also be built lightweight steel framing. This is an example in US. Right? With more research to be done in these aspects, we will be more confident in building it into a higher floors. And this, it can also be used for commercial lot. And some of the extreme examples would be this high-rise, which is 57-story tall in Changsha, China, which was built by one of the pioneer in China, where it was completed using steel structures within 19 days. I believe most of you have seen this online circulating, and we hope that this can be achieved not just in China, but in Malaysia. And last, of course, we know that the prefabricated decking and structure can also help speed up the construction of skyscrapers, just like this example, which is being completed in KL, Exchange 106. So all in all, we know that IBS with steel will be able to minimize your wastage on site because most of the fabrication are done in the factory. So you will not need to ship out those potential wastages on site. And of course, we are talking about IBS. So productivity is one of the key metrics where we measure. So IBS with steel will be able to increase or improve your productivity for construction. And again, come back to fast installation. So just now I mentioned the 3 types of IBS method, from site assembly to panelized to volumetric. So it can be done in fast installation. And of course, lightweight. As I mentioned earlier, during design stage, because the structure is lighter weight compared to traditional material, you are able to reduce your foundation cost. And not just that, and during the shipping of this or sending of this material to the site, you're able to lower the logistic cost. And when you're doing installation, you're able to reduce or minimize the usage of crane because of its lightweight. And because of all of the above, we are able to minimize the on-site labor required, but still delivering the same quality. Again, IBS, we still are able to deliver more design flexibility for your building design. And last is non-flammable. So you're allowing the dwellers to have a time gap for them to escape from the building in case of a fire. So let's go to the Q&A or questions that is asked by some of the listeners. So I'll share back to you for everyone's benefit. So what is the cost incremental if adoption of IBS in the project compared to conventional construction method? So the minimal cost increment, since the overall project cost would be minimized over the adoption of IBS. And what is the high strength to weight ratio difference between concrete and steel? Okay. So steel itself has a much better or much higher strength to weight ratio compared to traditional concrete because steel's lightweight property. So again, this itself can be seen from our technical bulletin, which you can get from online as well. So the next question is, what is the price difference between concrete panelized to steel panelized in terms of material cost? Yes, we see more residential and shop houses adopting lightweight steel framing. In terms of the cost difference, actually, we have no clear indication, but in terms of other indication, like I mentioned earlier, such as the logistic cost as well as the labor cost, there is a potential saving over there. Okay? So what is one of the key difference between IBS steel framing and conventional method? Concrete panelized has a lower material cost, but it is much heavier compared to steel panelized, resulting in higher transportation and require heavy crane for installation as compared to steel panelized. Given the advantage of lightweight steel frames and IBS systems, have this been used in conventional housing such as terrace houses and shop houses? Actually, yes, locally and overseas, we have seen more residentials or even shop lots or shop houses adopting the lightweight steel framing method. But I would like to add on to this answer. In fact, we see adoption over this technology because of the current pandemic, and we get increased questions about it as well. So what about the lifespan and maintenance compared to precast concrete structure? So the lightweight steel framing, once installed properly, wouldn't require any maintenance. Actually, its design lifespan is actually a lifetime, since each design shall be endorsed by the professional engineers. The next question would be, is it easy to modify the facility in manufacturing plant to suit for different design specification? So it is easy to design actually your building for different design specs by using software. So get the design printed digitally in a machine and have the parts manufactured, installed and assembled on site. So of course, we are referring to the computer-aided design method, where you can actually design lightweight steel framing using a dedicated software and see whether it can withstand a certain wind load or a certain weight itself. And we have seen in other countries, they are actually using this method to build light industrial buildings. So based on your experience, what's the disadvantage to IBS with steel structure? This one actually requires certain more design inputs and material production, whether it's done locally or is it done overseas. Based on your experience, what's the disadvantage for IBS steel structure? Let me just address that quickly. So when you have IBS with steel, you are not really looking at the disadvantage. You are looking at whether you can improve the productivity and also the design using this technology. So in terms of disadvantage, of course, you are looking at potentially different types of material being used. And of course, in the market, there are many, and some might be durable and some might not be. So you have to explore that later on. Does it increase the overall cost of manpower, since IBS system will be done by specialized workers? So the overall cost of manpower will be lowered as the IBS require less workers and faster and also easy installation. Of course, when you're talking about specialized, the examples that I showed you earlier, where we built the rural schools in Sabah, we actually train up 1 week's time, not just specialists, but also local workers. So it only requires 3 skilled workers and 7 to 10 not so experienced but trained workers on site for them to complete a school within 4 weeks. Specialty itself can be trained up easily, and given that the instruction is followed according to drawings, which is easy. I wouldn't oversimplify it, but it is as easy as following the codes, just like Lego building. Okay, so as long as you follow the drawings, it should not have any issue, and you do not really require a lot of steel workers, just one or few to guide them. So hope that answered your question. So the next one is, are all your design input and material production done locally? So well, the material production of lightweight steel framing is actually done locally, and the design input depends on the respective computer-aided design or computer-aided manufacturing method. And some commonly used design code would be like Australian standards. There's a specific reference of Australian standard, which is Australian Standard 4600, which covers quite a wide spectrum of how to design lightweight steel framing in different regions. Okay. But Australian standard, naturally, we would refer to Australian way of designing it. I hope through this session, you are able to gain some insight or knowledge. So we'll end this session. But first, let me give special thanks to Mr. Chu, who is a framing support specialist from Enduro Frame, and also Dr. Chua, who is a lecturer from Monash. So both of them has given their insight and input based on their expertise. And feel free also to connect with us through our various platforms that we have. And thank you for tuning in to Still Connect.